Good afternoon, everyone. Thank you for coming. Thank you for your support. I appreciate it. Thank you also to Shane, the cameraman back there who we can't see. Today I'm going to talk about the Large Hadron Collider, which is located in Switzerland and which I'll refer to from now on as the LHC. This is an immensely complex process, and I hope to convey enough information today so that by the time you leave, you can understand a little bit more about how this process is achieved. When most of us hear the word physics, what do we think? Snore, right? Most of us want to lay down and take a nap. However, I am crazy about physics because I like to understand how things work. And in my mind, physics is one way, actually the only way, for us to understand everything. The LHC is the world's largest machine. You can get a sense of the scale from the little tiny people down here. The world's largest machine was built to look at the universe's tiniest objects. It cost just over $4 billion to construct. That's a lot of money. What could we do with $4 billion? $4 billion, for one thing, could be the combined federal income taxes of you and 414,000 of your closest friends and relatives. Or $4 billion we could look at as being 4 times the 2012 profit of General Mills Corporation. That'd be an awful lot of Wheaties and Lucky Charms, wouldn't it? I'm going to cover 4 things today to help us understand how the LHC works. First, I'll be talking about what the LHC is looking for. Then I'll talk about what it's going to look like. Then I'll talk about how it's going to be found. And then finally, I'll cover any safety issues or concerns. So, what is the LHC looking for? It performs many experiments that look at results of collisions between many different subatomic particles. But its primary mission has been to find the Higgs boson. Higgs boson. Does that sound familiar to anybody?
Yeah.
Scientists weren't even sure that the Higgs boson existed, although they've had an idea that it was out there somewhere for a long time. And they assumed that the Higgs boson was the particle that was responsible for gravity. That we all understand. Gravity is what keeps us glued to the Earth, what keeps the Earth rotating around the sun, what keeps rain falling down instead of falling up. Yeah. So how's it going to be found? The mechanics of the LHC are staggering. The point of the LHC is to move protons around the accelerator until they're traveling at 99.9% the speed of light. At this speed, protons are moving around the 17-mile accelerator at 11,245 times a second. Just imagine that. That is 11 million miles a minute. It's huge. In order to achieve that velocity, the protons are speeded up by 9,600 giant magnets. And these magnets need to be cold to work most effectively. And when I say cold, I do not mean cold like ice cream. The magnets are cooled to minus 456 degrees Fahrenheit, which is only 2 degrees above absolute zero. And absolute zero is, in fact, the coldest temperature in the entire universe. Anywhere, anytime. Through a complex process, 5,600 bundles of proton, with each bundle containing 115 billion protons, are shot into the accelerator ring. That's a total of 645 trillion protons. 645 trillion protons, if packed fairly closely together, would occupy only the space of a single grain of fine sand. I know these huge numbers are mind-numbing, so let's look at a more easily understandable view to get an idea of the size of a proton. Imagine you're standing in the middle of Haleakala crater on Maui. Now, hold up a tennis ball. That tennis ball represents the size of the proton if the entire crater were the size of a single atom. When 2 of these protons smash together, they disintegrate into their constituent bits. And we already know what most of these bits are and what they do. So what's the Higgs boson going to look like? Scientists are looking for bits that are not familiar. These unfamiliar bits are then analyzed. Scientists have already guessed what the Higgs boson should weigh and how it should move. So when they find one of these bits that doesn't fit into a pattern we already know, but weighs and moves like what they've estimated the Higgs boson to move and weigh, then they've assumed they found it. Safety concerns. Before the collider was built, there were a lot of scientists that were very, very concerned that collisions between subatomic particles might form microscopic black holes that could suck up the entire Earth. Well, the experts concluded very, very convincingly that although this could happen, these microscopic black holes would be so tiny that they'd evaporate in a millionth of a second. Now there have been millions of collisions at the LHC, and none of them have caused the black hole that sucks up the Earth. We're still here, and the LHC is now considered to be completely safe. To me, Einstein put it best when he said that the most incomprehensible thing about the world is that the world is comprehensible. The LHC began operations on September 10th, 2008, and in only 4 short years, it found what everybody was hoping that it would find: the elusive Higgs boson. Now scientists the world over are poring over the details to understand the whys and hows of how the Higgs boson provides gravity to the universe. The great minds that built this machine understood that it could be the only way for the humans to understand further how the universe works, and they were right. Although expensive and time-consuming, this great piece of human technology has already made a huge impact on each of us. It has moved us closer to understanding everything. Are there any questions?
No.
Nothing anybody can think of. Great. You know what? I appreciate you taking your time out of your day to be here. I hope that you've enjoyed the last few minutes as much as I have. Hope to see you again soon. Thank you so much.